Okay, so first of all, today we're going to be talking about looping. I'm assuming that everybody here has, and please feel free to put yourself on mute if you don't want to talk right now. Um, but did everybody get a chance to watch that looping video, and were there any outstanding questions from it? Uh, I know we talked a little bit about the assignment right before recording. It seems like everybody's getting along with it just fine. So, okay. If there are no questions, then let's jump straight into the PowerPoint that I did drop into Blackboard. So if you had a chance to go through this already, that's great. You're one step ahead. But in the meantime, I just wanted to, run through this and we'll talk about it and ask and answer all the questions that'll go along with it. So of course, we know what looping is. It's what allows us to repeat statements. So we can create some bit of code that we will repeat it as many times as is necessary. Now, there's two major categories for loops, and those two are the count controlled loops here over at the left. So, count controlled is when we know how many times we want to do something. Like, let's say we wanted to print hello world to the screen 5 times. A count control loop would be perfect for that because we can just say, for the next 5 times that this loop executes, do this. Now, event controlled loops over to the right are a little bit trickier, and that's further broken down into 3 categories. But generally, they're all event controlled loops. So, what we end up with is there's a certain event that's going to happen. We don't know how many times this loop is going to run, but we know what event we want to listen for or wait until this event is true or false before we exit the loop. So, example number one of that is an end of file controlled loop. So, when we're reading a file, we don't really know how many lines there are. We just have to keep reading until we get to the end. And then that's when we know how many lines there were in the file. So really, we just keep reading until we stop getting data. Once we stop getting data, that's our event that says, okay, we're done looping, exit out of the loop. Okay? Then we have sentinel controlled loops, which we'll talk more about later, and flag controlled loops. Very similar concepts, though. Both of those are very similar concepts. The only one that kind of stands out as being a little different is the end of file controlled loops. Okay, so in this PowerPoint, we're going to just be looking at while loops. In the video that I put out there, I went into detail about while, do while, and for, the structure itself. But in this one, let's just focus on the while and use and figure out all the different types of loops that we can use and how we would make it in a while loop. Some terminology to go through. An iteration is one pass through a loop. So if I said print this hello world to the screen 5 times, that would be what I'm saying is 5 iterations of the loop. The loop test. This is the logical expression that is evaluated as true or false, and the decision is made whether to enter or exit the loop. So we're bringing back our logical statements or logical expressions. And then we have our terminating condition. This is the condition that causes the loop to be exited. And infinite loop, it's a loop that never ends. That's pretty self-explanatory, right? Your program will eventually crash, and it's never good whenever you have an infinite loop because it can be sometimes very difficult to close that program. And then a loop body. These are the statements that execute within the loop. So this is basically the logic. This is if you wanted a loop that prints hello world to the screen 5 times, like I've been saying this whole time, then your loop body would consist of that cout statement. Everything that exists around the loop that supports the loop is not part of the loop body. Okay. Now, first are count controlled loops. These are our loops, like I said, where we are counting, we're doing something a finite number of times. We're not waiting for some event, we're doing it 5, 10, 15, 20 times. So a count controlled loop uses a variable that's called an LCV, or a loop controlled variable, in the loop test. So I'm going to say LCV for short, but that is the loop control variable. Okay? Now, the steps for a count controlled loop, this is practically the same for all of the different types of loops. We'll compare and contrast them here in a minute. We're going to, step one, declare and initialize our LCV. So if we're keeping a count, we need a finite whole number to keep a count. So we should use the data type of integer, probably. And with that integer, we're going to declare and initialize it to 0 or 1. And then we have a loop test. This tests the LCV. So this tells us, like, if our count is less than or equal to 5, that will be true until our count becomes 6. Simple example for a loop test that it could be. So if the loop test evaluates to true, we enter the loop. Now, moving on to the loop body, these are the statements that will be executed within the loop. Okay, this is just the work that's going to happen, the work that we want to do. The reason why the loop exists, basically, is for the loop body. Now, lastly, we need to modify the LCV, and it's important to know here, and the reason why it's here is because if you forget to modify the LCV, your loop will become infinite, especially in a count controlled loop, because you need to increment the count, how many times you've been through the loop. If you never increment the count, and we're always checking if it's less than or equal to 5, let's just say, then, and you initialize it to 1, it will be 1 forever. You'll never exit the loop. It'll just keep doing the loop body repeatedly. Now, here's an example of using a while statement for a count control loop. So we declare and initialize our LCV, int count equals 1, right here. So if count is 1, so when we declare and initialize the LCV, then control goes down to here, this while statement. And this is the loop test. So what the computer is going to do is it's going to say, okay, is count less than or equal to 5? And well, that would be true on the first pass, right? Because 1 is less than or equal to 5. So since this is true, we will enter into the loop, and we will execute the loop body. So within the loop body here, we have a cout statement that just says pass number and then outputs count. So as you can see from the output, we output pass number 1. The next step we have is modifying the LCV. So we take count and we add 1 to it. Everybody here remembers the plus plus operator, right? No questions about that. Okay, good. So count becomes 2. And then what we do is it goes back to the top of the loop and it executes the loop test again. So now count is 2, so it'll say, well, is count less than or equal to 5? That's still true. So we go into the loop body, cout pass number 2, increment count. So count becomes 3. We go to the top, 3 is less than 5, less than or equal to 5. That's true. So we go into the loop, pass number 3, boom, this becomes 4. Go back to the top, is 4 less than or equal to 5? That's still true. Cout pass number 4, modify the LCV again, it becomes 5. Back to the top, is 5 less than or equal to 5? Yes, it is still. Cout pass number 5, count plus plus, so count becomes 6. Now we go back to the top of the loop, is 6 less than or equal to 5? Finally, it's false. So what we do is we exit the loop and we go outside of the last curly brace here. And then control go just continues like normal through your program. Any questions about how I stepped through that? Because you're going to need to know how to trace through loops.
No.
Okay, good. So another one here. This is going in the opposite direction, though. Not to confuse anybody or anything, but we can do a count control loop going backwards as well. If we wanted to count backwards from 5 or something like that. And what this is doing is we're keeping track of a sum. So count starts at 5, sum is 0. Our while statement says while count is greater than 0, which is true initially because it's 5, so 5 is greater than 0. Sum plus count. Sum is 0, count is 5, so sum gets 5. Count minus minus, just decrementing. So it becomes 4. 4 is still greater than 0. So we go back into the loop body, do it again. Sum gets to be 5 plus 4, 9. Count minus minus, we go to 3. And it's the exact same process. We end up hitting 0, and then we have is count greater than 0. This is false. And then we output the sum. So that was count controlled loops. We saw going backwards, we saw going forwards, incrementing, decrementing. And I just want to show this one more time that these are the steps, what I would call like the anatomy of a count controlled loop is declaring and initializing the LCV, doing our loop test, our loop body, and then modifying the LCV. Now, if we move forward, an event-controlled loop, the terminating condition depends on some event occurring while the loop body is executing. So we need something that is kind of like, it is our LCV, it's our loop control variable, and we need to modify it in some way, but we don't know when it's going to end exactly. So the first example of this is an end of file loop. So we don't know how much data is in the file. When we reach the end of a file, our DN is going to tell us when to exit the loop. After the last value in a file is read, the input stream is at the end of file state. That end of file state evaluates to false, and we know to exit the loop. So the only thing that's really different for an end of file controlled loop is instead of declaring and initializing the LCV, we still need to declare and initialize our DN, but we need to do this priming read. This priming read, think of it as priming the pump, okay? I don't think anybody here is like probably ever had a well in their life, but when Mark Guys taught me this, okay, I remember he had explained it like that, and it really stuck with me because I did. So you always have to like pump it a few times in order before you start getting water out. It's the same thing with like a standard a spray with a spray bottle, right? Sometimes you just got to pump it a couple times, and eventually it'll start spraying. Same thing. So you read that first value from the file before you start your loop. And we'll see that here in a second. Now, then you do your loop test, same thing. Is there still data in the file, though, is our question, rather than saying, is something greater than something else or is something less than something else? And then we do our loop body. This is where we process the data that we read from the file. And then lastly, we modify the LCV. How we modify the LCV in this case, we just read the next line of data. So technically, the priming read and the modify LCV are the exact same code. Now, if we look at this, we can see our IF stream DN. And hopefully this still looks familiar, right? I know that we did a file processing a little while ago. We haven't talked about it too terribly much since, but hopefully you haven't forgotten. Now, we're declaring an int num that we're going to read from the file. dn.open num.dat. Here's num.dat. So we can see that there's a number of numbers in there. Now this is our first step to our end of file loop. It is our din and extraction operator num. This is our priming read. Now our loop test is this, just our while din. This while din will evaluate to false if there is no more data in the file. Okay? It will evaluate to false if you tried to read the next value, but there was nothing to read. So, this would be true initially. Num would be 33 because that's the first integer value that we have in the file. And then we would enter the loop body. The loop body is here, just this one line where we're just counting the num and then end line. So we would cout 33 and an end line, and then we would modify the LCV by reading the next value from the file. So, and like I said, the priming read and modifying the LCV, the exact same line in this case. So we read the next line, and now num is 5. That's the next integer value in our file. We loop back up. Is din true? Well, yes, we successfully read a value from the file, so we continue. So we would output 5, and let me just skip ahead a little bit here. 5, 6, 7, 6, 8, and then lastly, we read 99. While din, well, it's true. It's true because we didn't read it. Because we did read something. Excuse me. So we read 99 from the file. So we enter the loop and we execute the loop body. So we cout 99 and an end line, and then we extract the next number. Well, now there's nothing left to read. So instead, num is not going to be changed. Num will stay 99. But din will switch to, I'm just going to say, it's going to switch to false, but it's actually in the end of file state, okay? But it will evaluate to false now. So when we go back up here, while din, well, this is false now. So when we exit, we'll go straight down here to the din.close, close the file, and exit the program. So you'll see, what we actually did was try to read one extra line of data, but we didn't, there was nothing there, so while din evaluated to false, and we exited the loop. Now, if we pretend really quick that this data file was empty, there was nothing in it, what would happen is you would do your priming read, and you would read nothing, because there's no data in here. While din would be false right away, you would exit, go around, and close the file. So that priming read is important to do before your loop test, specifically to, there's a few more reasons, but one of the best reasons at least is specifically so that you can account for that situation where the file exists, but there's nothing in it. Any questions about the end of file loop?
No. I'm good, I think.
Okay, good. I just want to point out one more time too, notice that the din, it's just like cin. We read it the exact same way.
Right.
Just from a file instead.
Right. Okay.
Okay. Next, our sentinel controlled loop. Don't let this intimidate you at all. It is just a loop that is controlled by a special value. This is still our loop control variable, but we call it a sentinel value because everything depends on this sentinel value. Everything, we're not counting because then that would be a count control loop. But what we're doing is we're, like it says here, we can be reading from user input and it may be from a file. So what we're saying is, let's say that we wanted to read input from the user until they input an even number. We would use a sentinel value of whatever we're reading from the user. And we'll just keep saying, well, while this is not divisible by 2, keep looping the user, asking them to input a proper value. So our Sentinel controlled loop has a priming read just like our end of file loop. So what this is just getting that initial input from something. Like, for example, if we wanted to, like I said, about getting an even number from the user, we can do that, but we have to get that initial value. And then we say, well, while that value is an odd number, ask them to try again, and then get another input from the user. Next, we do a loop test. Often it looks like this, while the value does not equal some Sentinel value. And then our loop body, this is the statements to be performed and repeated. We've seen this already. This is where the actual work happens. Modifying the LCV, this is reading the new file. Can be input from the user or input from the file, just like our priming read. And just like our end of file loop, they should look exactly the same. I'm going to say 99% of the time, it's the exact same code. So this is an example of a Sentinel controlled loop where we are summing up numbers that the user inputs, and we're saying, if you input -1, I know that you want to exit the program. So we're going to keep summing numbers up until the user inputs -1. Then we will exit and display to the user what the sum is. So if we look at it here, if I go back really quick, our loop test sometimes looks like this, where value does not equal Sentinel value. Well, if we look at this here, this is the exact loop test that we have, where the num does not equal a Sentinel value, which is a constant, and our named constant up here is -1. So we ask the user to please input a number to sum, enter -1 to exit, and our priming read is cin num. So we're asking the user to input a number, they input a number. In the output here, the user inputs 2. So we say, well, while 2 does not equal -1, which is true because 2 does not equal -1, then we take the sum, which is initially 0, sum plus num, 2 plus 0, store that in sum. And then we see out, please enter a number to sum, enter -1 to exit. Just the exact same thing as our priming read was up here. Our modify LCV is down here. So the user inputs another number, 4 in this case. We go back up. Is 4 not equal to -1? Well, that's true. So we keep going. We execute the loop body again, modify the LCV. Let's say that the user inputs -1 now. So now the user inputs -1. Is -1 not equal to -1? Well, that's false because they are equal. So we exit the while loop and we execute the next line of code here, where we see out the sum is whatever the number is. Any questions about Sentinel controlled loops? All right, everybody's doing pretty good today. That's good. Hopefully I'm not just putting everybody to sleep too.
No.
Okay, good. Thank you for piping up, Michael. Okay, so next we have our flag controlled loop. It is controlled terminated with a special value called a flag. Now this flag is a Boolean value. So technically everything, all these loops that we're talking about evaluates to a Boolean value. So what makes a flag controlled loop any different? Well, not much. Not much, really. The difference is what we usually do is we just have a Boolean value and we figure out if that Boolean value should be set and if we should exit the loop. So let's step through this code actually before I get ahead of myself. So first, int num, int sum equals 0, bool negative equals false. Please enter a positive number to sum, enter a negative to exit. And then we see int num. So that's our priming read. Well, technically this whole thing would be considered our priming read, because now we have if num is less than 0, negative equals true. Okay, so we need to get input from the user, and we need this if statement that says if the number that they inputted was less than 0, then negative equals true. Now we say while not negative. So remember that exclamation mark in front of it means not, so we invert it. So that's false right now if the user input a positive number. Let's say the user input true, just like our output here shows. So if they input 2, is 2 less than 0? No. So we go around. So negative is still false from up here. So while not false, that evaluates to true. So we enter the loop and we do sum plus num. That's 2. And then we modify the LCV in the exact same way. So we ask the user to input another number. We get that number. And we say if that number is less than 0, set negative equal to true. Let's say that the user inputs negative 1 next. Is negative 1 less than 0? That's true. So we go in, negative gets true. Now when we go back to the top and we do our loop test, we will say not true. Well, not true evaluates to false. So we exit the loop and we are done. Very subtle differences between these two types of loops. And so if you ever see that it's just a straight up Boolean value, I want you to think flag controlled loop. And I want you to write that down, okay? Write that down right away. Any questions about our flag controlled loop? All right. Well, that is actually the end of what I wanted to talk about. What I really wanted to touch on was, and again, just to summarize the differences between the earlier video that I did and what I wanted to talk about here, was the fact that I went too far. The end of file controlled loop, I kind of crammed everything together, and I called the priming read the initialization declaration initialization of the LCV. Technically true, but we call it the priming read. Okay? But other than that, everything else is the same. So you'll notice, so again, just to compare these two, if I go back here, count controlled loops. Step number 1, declare and initialize LCV, loop test, loop body, modify LCV. Now when I go to the end of file loop, the end of file loop, step 1 is priming read. That's the only difference. Loop test, loop body, modify LCV. Okay.